from some of the stuff. Remember that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. Remember that this is 0. If you go to there, this is 90. This is 180. This is 270. We're going in that direction, and then this would be back to 360. Think about the quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. When you think about the special right triangles, the 45, 45, 90, you're talking about a triangle that looks like this. That hypotenuse is 1. This is 45 degrees. This is the reference angle. This is the square root of 2 over 2. And so is this, the square root of 2 over 2. In a 30, 60, 90 triangle, when you have the 60-degree reference angle, and it looks like this. Here's a 60-degree reference angle. The hypotenuse is still 1. The opposite side is a square root of 3 over 2. And the adjacent side is 1/2. When you work with a 30-degree reference angle, the hypotenuse is still 1. The opposite side is now 1/2. The adjacent side is a square root of 3 over 2. We had that yesterday. All that is not new from yesterday. So we're going to use this information to draw triangles in what's called the unit circle, because it's 1 unit away from the origin. Think of spokes of a wheel. So the kind of question that you're going to have would be something like this. Which quadrant does theta, and theta is an angle. So when you see the Greek letter theta, that refers to an angle. This letter is theta. It's a Greek letter, and it's usually used for angles. So which quadrant does theta lie in if the following statements are true? The sine is positive and the tangent is negative. So when you think about that, let's think about what this looks like. The sine is the opposite over the hypotenuse. The tangent is the adjacent, or is the opposite over the adjacent. So remember now, if the sine is positive and the tangent is negative, think about know that the hypotenuse is always positive. So we're always going to say it's positive. We're actually always going to say it's equal to 1. So when you think about, like, if the sine is greater than 0 or positive, and the tangent is less than 0 or negative, notice that the only way that can be true is when the adjacent side is negative. Because we already know that the sine is, in order for the sine to be positive, the opposite and the hypotenuse would need to be positive. In order for the tangent to be negative, the opposite and the adjacent have to have different signs, but you already know from logic that the opposite side would have to be positive. So if you're doing this problem, and I admittedly don't know why I just went to a full screen here, so I'm going to shrink it down. when you're asked this question right here, where the sine is positive and the tangent is negative, and you think about where that would be a triangle that would have to be drawn so that it's in this quadrant. Because think about this reference angle where the opposite side is positive and the adjacent side is negative. It's the only place it could be. So the answer is, for this one, is got to be in quadrant 2. And when you kind of go through it, you'll see that theta needs to lie in quadrant 2. So if we go here and we submit the answer, it'll go through and it'll explain the same kind of things that I said. Okay? So you'll have to do some problems similar to that. You'll also have to do something like this. In which following quadrant does theta lie in if the following statements are true? Now, let's go back to this. Remember that if that's true, if this is SOHCAHTOA, and that goes with sine, cosine, and tangent, right here, sine, cosine, and tangent, remember that you already have these notes somewhere, that the sine of theta is the opposite over the hypotenuse, which means the cosecant of theta is the hypotenuse over the opposite. So the sine and the cosecant go together. The cosine is the adjacent over the hypotenuse, and the secant is the hypotenuse over the adjacent. So those two go together. And then the tangent, theta, is equal to the opposite over the adjacent. So the cotangent of theta is equal to the adjacent over the opposite. So those go together. So let's think about this. It says, on this problem, it says the secant. So here's the example that we're going to do. The secant of theta is greater than 0, and the cotangent of theta is less than 0. So let's think about what that looks like. The secant of theta is greater than 0, and the secant of theta is the hypotenuse over the adjacent, and the cotangent of theta is the adjacent over the opposite. So in order for this to be true, notice that the opposite side needs to be less than 0. The opposite side needs to be less than 0. So when you think about drawing a triangle with the opposite side being less than 0 and the adjacent side needs to be greater than 0, the adjacent side is coming from when we go out in either the left or the right direction. The opposite side is going to come from when we drop, right? This is the hypotenuse. So this is the opposite side. This is the adjacent side when we draw the triangle. So we need to be in the fourth quadrant in order for us to generate this kind of relationship. So when you go here, you go to fourth quadrant, and if we show the solution, it'll say it's in the fourth quadrant. So we show the question here. It'll tell us, oh, there it is. Perfect. So take a look at those. Now, when we go to the exact value, we talked about these yesterday. Cosine of 225. So 225 is going to bring us, here's to 180. We need to go 45 more. So right there. If you think about where that is, that's a square root of 2 over 2 problem. The cosine is the adjacent side, which is this side right here, over the hypotenuse. Notice we've gone back this direction. So the answer is negative square root of 2 divided by 2. And when we show you the solution, that's what we're going to have here. So if we submit this answer, we should get the right answer, and they show you where it is. Same kind of thing with this one. Only now we don't get to drag that little circle around. Now we just have to figure it out on our own. So if we're doing the cosine of 330 degrees, think about what that looks like. 330 degrees. Well, you know this is 0. This is 180. This is 270. And here we're back to 360. So 330 degrees is just short of 330 degrees would be here. This is a 30-degree angle. So when we drop this triangle, go back up and look at your triangles. This is 1, this is 1/2, this is the square root of 3 over 2. Now this 1/2 needs to be negative because we went down. The other ones are positive. So the cosine is the adjacent over the hypotenuse, or just that. So if we go here, we type in the square root of 3 divided by 2, we should get the right answer on that. And they don't maybe draw the triangle, but you get the idea of where these things are. Hopefully that helps. Hopefully you understand what's going on there. And if you have any questions, please let me know.